In this video, we are going to talk about how to calculate acceleration. So acceleration is defined by the following formula. Acceleration equals final velocity minus initial velocity over time. And guys, don't get confused by this little f by the v here, okay? That just means final velocity versus v in the little I, or what we call v sub I. That's just going to be initial velocity. Velocity is in units of meters per second. Time, we still have to be in units of second here, and units of acceleration are going to end up being meters per second squared. So make sure you have all your units straight when you're solving these problems. Let's go ahead and dive into our first problem. While traveling along a highway, a truck driver slows down from 55 meters per second to 24 meters per second in 17 seconds. What is the truck driver's acceleration? So I'm just going to write our formula up at the top so we remember what it is, and then I'm going to line up all of our variables down here below. Now let's look and see what we have in the problem. First, it's asking us, what is the truck driver's acceleration? Oops, let me get that off the screen. So acceleration gets the question mark. In terms of final velocity, it kind of tells us exactly what that is in our formula. It says 24 meters per second is the final velocity. But we can also figure that out. It says a truck driver slows down from 55 to 24. So it was originally starting at 55, then he started hitting the brakes, and he slowed down 2, so that's the end. So end is final, start is initial. Our initial velocity is going to be 55 meters per second, and our time is going to be 17 seconds. Everything here is in the correct unit, so we just need to plug it in for the formula. Our final velocity is 24 meters per second. We're going to subtract that from 55 meters per second, and we're all going to have it over 17 seconds. If we put this in our calculator, it is going to be negative 2.2 meters per second squared. A few things to note here, guys. First of all, when you put this part in your calculator right here, make sure, okay guys, make sure you are telling your calculator 24 minus 55. Then you're going to want to hit enter. That's going to give you a negative 31. Then you're going to want to say negative 31 divided by 17, and that's how we get this negative 2.2 meters per second. What you do not want to do, this is what you do not want to do. So let's write do not, okay? You do not tell your calculator 25 minus 55 divided by 17. This is not correct. You will get the incorrect answer because what you're telling your calculator to do is saying 24 minus 55 17ths. This is not the same as what we just did. Remember that you have to tell your calculator the correct operative steps. This does not follow the same order of operations. So make sure you do not tell your calculator this. Tell it to subtract first, hit enter, and then divide by the time. Also, the second thing here, we have a negative acceleration. Can acceleration be negative? It can be negative. When we have a negative acceleration, what that means is that we're slowing down or we're decelerating. Again, in the problem, it says slow down. So based on the fact that it says the truck driver slows down, we should automatically be able to predict that our resulting sign is going to be negative in this problem. Whereas if the truck driver were to speed up, as we see in later on problems, that's going to be an increase, so you're going to have a positive value. So it's fine that this is negative, again, because it's slowing down. For our next problem, a parachute on a skydiver opens and changes the speed of a diver from 100 meters per second to 65 meters per second in a period of 7 seconds. What is the acceleration of the skydiver? So first of all, let's think about this qualitatively. It changes the speed. We start at 100 and we're going to 65. So is that slowing down or speeding up? Of course, that's slowing down. So if it slows down, what should the sign be of our acceleration? Should it be negative or positive? Well, if it's slowing down, just like we discussed in the last slide, our acceleration should be negative. So we need to make sure that we have that negative acceleration in the end. If we don't get a negative, that means you probably did something wrong and we need to go back and check math. So let's line up our steps. It's asking us to solve for acceleration. That gets the question mark. In terms of final velocity, we end, or the skydiver ends at 65 meters per second and starts at 100 meters per second. The time on this is 7 seconds. Everything in here is in appropriate units. We have velocity as meters per second and time as seconds, so we can proceed with filling everything into the equation. So it's going to be 65 meters per second minus 100 meters per second, all divided by 7 seconds. Again, make sure you're putting this math in the calculator correctly. Go ahead, stop right now, get out your calculator, solve this math, pause the video, and see if you get the correct answer as I do. So you should have gotten -5 meters per second squared. If you did not get -5 meters per second squared, again, make sure you're doing your subtraction first, hitting enter, and then dividing by 7. And that's going to be our final answer. A car traveling at a speed of 23 meters per second encounters an emergency and comes to a complete stop. How much time will it take for the car to stop if its acceleration is -3.5 meters per second? So let's break this problem down a little bit. Now here we go ahead and tell you that this stop is the final velocity. Remember, if you're stopped, you're not going anywhere. Your speed is nothing. So that's how we get this 0 meters per second here. In terms of the acceleration is a negative. What does that mean in terms of acceleration? It means that the car is decreasing its speed. So let's write the equation down. Fill out our variables on the side. It gives us acceleration this time. That's -3.5 meters per second squared. It's asking us how much time will it take for the car to stop? In terms of that, that means we're solving for time, so that gets the question mark. Our initial velocity is 23 meters per second, and our final velocity is, of course, stopped or standing still, or the car is still, so that's 0 meters per second. In terms of our formula, we are going to have to rearrange and solve for time. Here, there's a little bit more variables to this step, but that's okay because we can still do it. So I'm actually going to go ahead and rearrange when all the variables are still like this letter format. If you rather plug in your numbers first and then rearrange, you also can do that. So time is going to be in our denominator, and we definitely want to get out of the denominator first. So we're going to multiply both sides by time. So this is going to give us time times acceleration equals velocity final minus velocity initial. Again, we're trying to get time on a side by itself, so we want to divide both sides by acceleration. It cancels out on the left, and our resulting formula, I'll write it in a different color here, our resulting formula is going to be time equals final velocity minus initial velocity over acceleration. Now, if you don't want to rearrange and solve every time, guys, just write down this formula. Use it, okay? You can do that. That's no worries. Now that we have time on a side by itself, we can definitely solve for it. All of our units are in the correct format to use this equation, so now we can just plug in our variables. So final velocity is 0 meters per second. We're going to subtract the initial velocity, which is 23 meters per second, and we're going to divide by acceleration. Let me erase that there. Acceleration is -0.35 or -3.5 meters per second squared. Let's do our subtraction on the top, hit enter, and then divide by -3.5. This is going to give us a value of 6.6 seconds. We have a positive value here. Remember, this top term, 0 minus 23, that gives you negative 23 meters per second. A negative divided by negative is a positive. Also, think about it, guys, just logically. If you have negative time, we can't go back in time, okay? We can't do anything to stop it and roll back, so you should never get a negative time. So this is 6.6 seconds, and that's going to be the time it takes for this car to stop given its initial velocity. Let's take a look at this problem right here. A ball rolling down a hill for 2.9 seconds has an acceleration of 3.3 meters per second squared. If the cart has a beginning speed of 1.5 meters per second, what is its final speed? We line up our variables. It's asking us to solve what is its final speed. So final speed is going to get the question mark here. It gives us an acceleration of 3.3 meters per second squared. It gives us a time value of 2.9 seconds and an initial speed of 1.5 meters per second. If we look at this equation, we are going to have to rearrange and solve for final velocity here. And that's not a problem. We can do that. Again, I'm going to rearrange before entering in my values. So we always have to get that denominator. We have to get rid of that denominator because it can definitely be a problem. So we're going to multiply both sides by t. This cancels out the time on the right side, and it's going to leave us time times acceleration equals final velocity minus initial velocity. Now we have to still get final velocity on a side by itself. Since we're subtracting initial velocity in order to get rid of it, we need to add initial velocity to both sides. That's going to cancel out on the right. And so our resulting formula is going to be final velocity equals times acceleration plus initial velocity. All of our units are in the correct format to use this equation, so we can proceed. So we are given a time of 2.9 seconds times acceleration, which is 3.3, and we are going to add that to the final velocity of 1.5. Remember your order of operations. You have to do multiplication before you do addition. If you plug this into your calculator, again, go ahead, pause the video, do that now. Let's make sure we get the same value at the end. For this particular problem, I got a final velocity of 11. Oops. Well, this just is not wanting to write the answer now, is it? Let's get back on track here. All right, there we go. This is going to give me a final velocity of 11.0 meters per second. For our last problem, we are looking at an airplane that increases its speed from 35 meters per second to 78 meters per second in 6.9 seconds. What is the acceleration of the helicopter? Again, let's think about this very conceptually. We know that's funny. It says airplane up here, but helicopter there. No worries, probably just a typo. We can still solve the problem as is. So again, we're increasing our speed. So if we're increasing our speed, what should be the sign on acceleration? Should it be a positive acceleration or should it be a negative acceleration? In this case, because we're increasing our speed, our final acceleration value should be positive. In terms of, let's see, what is this question asking us? Of course, it's asking us the acceleration. So that's going to get the question mark. It gives us a final velocity of 78 meters per second, an initial velocity of 35 meters per second, and it increases the speed in 6.9 seconds time. This one's going to be very straightforward. We really don't have to do any rearranging of the formula. We can just do what I like to call plug and chug. So putting in our values, 78 minus 35 meters per second divided by 6.9 seconds. This is going to give us an acceleration of 6.23 meters per second squared. Now, in all these problems that I've done, it's talked about, or it's given us, hey, you know, it really lets us know, hey, this is the initial speed, hey, this is the final speed, and this is your time. So it's very nicely set up. It tells you what all the variables are, but in reality, that's not going to be there always, right? But you can always tell, at least by units, what things are. So for instance, this is meters per second. We know that has to be a velocity. And then time, that's seconds, whereas acceleration is that meters per second squared. So you can also always look to your units to see what variable it could potentially be. Anyways, that's going to wrap up this video. I hope this helps you a lot. Again, if you have any questions, just send me a message. I'd be more than happy to answer them for you.